Hello everyone, this is Himabindu from the Department of CSIT. Today in this video I would like to explain about the concept called pumping lemma for the regular sets. So till now we have discussed about what is meant by regular languages, what is meant by regular expressions and what is meant by regular sets. So here with these regular languages and regular sets, how we have to prove that this is the regular language or not. So here we are using some techniques. What is those technique? We will move into the slides. So here we have to prove that the language, it should be a regular language or not. So what is meant by proving a regular language is a language or not. So here the class of languages which are accepted by the DFA, by NFA and by epsilon NFA. So here the languages which are accepted by the finite automata. So what is the finite automata? How many machines are there in the sense? The finite automata with output. Without output it is having, without output. So without output it is the finite automata, DFA, NFA and epsilon NFA. The language which are accepted by these three is also a regular language. And they are also the language defined by the regular expression. So here the languages defined by regular expressions is also a language. And not only every language is a regular language. So here whatever the languages which are defined by the finite automata, those are all not belongs to the regular languages. We have to use some technique. What is the technique? In the sense, pumping lemma. So here is the pumping lemma we are using further. We have to check whether the language is regular or not. The given language, whether it is accepted by the DFA or NFA or epsilon NFA or by the regular expressions, those languages we have to check whether these are all regular languages or not by using the pumping lemma. So what is the application of this pumping lemma? So here the application of pumping lemma is to be applied to show that certain languages are not regular. So here we are taking some languages and we are checking that language is regular or not. So here is the application. So where we are using this pumping lemma technique in the sense to check whether the given language is regular language or not. And it should be never used to show the language is regular. So by using this pumping lemma, we can't state that the given language is only a regular language. We can say that by using this technique, we can prove that it is not a regular language. And with this same technique, we can't prove it is only a regular language. And if the language L is regular, it satisfies the pumping lemma. So if the language L, it satisfies the pumping lemma. We are giving this what is meant by pumping lemma length and we will discuss in the next slides. If L does not satisfy the pumping lemma, it is not a regular. So here some conditions we are going to discuss. We have to satisfy all the conditions, then only it should be a regular language. And what is this pumping lemma? So pumping lemma of regular languages. Here is one theorem which was taken from the textbook. And here for any regular language L, there exists an integer n such that for all W in the language L. And here what is this W? So here L is for language, what we are checking whether it is a regular language or not. And here the length which is having the W. So W is the word which is formed by using this language, particular language. And suppose this language, it is having the input symbols A comma B. And what is the word with this language in the sense? It starts with A, B or the substring. And it is starting with substring. This is substring. And we can add starting string as starting input symbol AB, and we can also form a static symbol B. So like this, there is a language. So here only the substring is AB. So there is no limitation of starting and ending. So here this A, B. So for this kind of language, we form some strings. So those are all, we'll take one string. So what is that? A, B. So this is the word. So what we have taken from the given language. So here the length of the N and it is a length of W greater than N. And we will also discuss what are the conditions we have to satisfy for this pumping lemma to prove that the regular language is a given language is a regular or regular language or not. So here we have taken one input string. What is that input string? What we have formed from the given language, which all belongs to the language. So we have to take that input string and we have to divide into three parts like X, Y, Z. Suppose here we'll take one example. W is equal to A, and B. So here this is one example where we have taken from the given language and it is formed the W string. So here we have to divide this into a three parts. So this string should be divided into three parts. We will take these two terms as a X and these two terms as a Y and these two terms as a Z. So we have divided the given string into a three parts. And based on the three parts, we have to check whether the two parts of x comma y length should less than or equal to n, and the length of only y is greater than or equal to 1. So we have to satisfy the three conditions in this pumping lemma to prove that the regular given language is regular or not. So first condition is the two parts like x comma y length should be less than or equal to n, and y, the only y part is greater than or equal to 1, and this is one more condition. And we have to pump a length, and we here the I is the value we have to give from 0 or greater than 0. So greater than or equal to 0, and we have to pump that to the middle part, that is y, and we have to, after giving this pumping length, and also we will get one language. So what is the, and that string is belongs to language or not, we will check by these three conditions. And here consider all the possible splitting of W in XYZ with the desired properties. So desired properties in the sense here the y what we have taken, it's a combination. In case of two input symbols are there, it should be in the form of a combination of two input symbols. Then we will get a correct answer whether this language is regular or not. So here we have taken y is equal to a power m, and comma, this m should be 1 less than or equal to m and m less than or equal to n. So this is the condition while choosing the y part. And here the string W is divided into three parts, and we have to check for the three conditions, and we will prove that whether this given language is a regular language or not by using this pumping lemma. And here we will explain with this more clarity about this pumping lemma concept by using some examples. So here some examples we have taken. So here L is equal to a language which is formed by the a power k. So k is a prime number. So here a power k. So let us write a is equal to a power k, and where k is equal to k is a prime number, and here we have to prove this language. So k is a prime number. We have to prove this language is regular or not. Regular or not. So by using this pumping lemma, we will show that it is a given language is regular or not. So first of all, what we have to do in the sense k, what are the prime numbers we have to write. So what is the prime numbers? So let us write prime numbers 3, 5, 7, 11 and so on. So with this, we will form the language. So a power 3, a power 5, a power 7, a power 11 and so on. And here we just elaborate this language. So a power 3, a power 5, and a power 7 and so on. So here is the language. In this language, first step what we have to do, we have to take the W. So W will take a power, we will take this a power 5, that is nothing but a, a, a. And what is the length of this W is equal to 5. So here we have to check the first condition, x is equal, W is equal to, we have to divide that x, y, z. So here x, y, z, what we have taken, so x, so we will take this as a x, let's me write clear, W, so and this is, so I will take this as a x, y and z. So here first condition what we have to do, so x, y, length of x, y is less than or equal to n. So here xy is nothing but xy. So xy is a, 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 a. And here length is equal to 4 or greater than or equal to 5. So it is satisfied. And here one more condition, length of y is greater than or equal to 1. So here what is the length of y, in the sense what is this a, how much length it is, a. So it is 2 and it is greater than or equal to 1 and it is satisfying. And these two conditions are satisfying. And one more third condition is about x y power z, and here I is equal to what we have to take. So if you take I is equal to 2, or we'll start from 0. So we just stated that I is greater than or equal to 0. So we will take I is equal to 0 and we will prove that whether this language is given, language is not regular or not. So I is equal a is x and y is equal to y I power 0 and here a. So a power 0. So a power 0. So let me write here. So y is equal to a and power of 0 and with a. So what is the output? A. And here we are getting the length in this language which is belongs to language. This given language. Why? Because triple A is already there in that language. And let's take I is equal to 1 and here x, y power I, z is equal to a power 1 and a. So here a, 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 and this is also belongs to the language, this language, and here the length same, this same string is there in the given language also. And let's take I is equal to 2, I power z is equal to a power 2 and a, and we have to elaborate a and a. So how many are there? We have, this is also belongs to this language. A. Okay. And here I is equal to 3. So is equal to 3. So here the string a, and here a 3 times we have to write. Right. So here this is the string which is a power 9. So which is not belongs to this language L. So here we have to prove that until the I is equal to 3, we have not reached the language. So same language is not accepted. So here this, how we have to prove that this given language is not a regular language by using this pumping lemma. We have to take this I value until we will get the regular, not a regular language. So this is how we have converted, we have proved that by using the pumping lemma, it is not a regular, given language is not a regular language. And next example. So here we have to take the W which is belongs to A comma B and whole star. So we have to prove that whether this given language is not a regular language, given language is regular or not. So here W is equal, L is equal to W and W which is belongs to, which is having A comma. So it is a combinations of A power P, B and A power P, B. And here we will prove that we will give that P is equal to 2, and here we will elaborate this language A power 2, B, A power 2, B. So why? Because 2 W and W. So it is a WW combination. So we will elaborate AAB, AAB. So this is the W. So where we have to divide that into a XYZ. So how to divide this XYZ? A, B, A and A, B. So we will divide this X and Y and this is Z. So here first step what we have to, length of XY. So first step, length of XY. So XY is equal to A, B, A. So what is this length? Less than or equal to 6. So here is the length, n is equal to 6. So here this condition is satisfied. So why? Because 4 greater than, less than or equal to 6. And second, length of y, it is less than or equal to, greater than or equal to 1. So what is the length of y? BA. So here 2 greater than or equal to 1. So it is also satisfying. And third step, so we have to take I is equal to, we will take from 0 onwards. So I is equal to 0 and let's take this x, I, y power I and z. And what is this x value? So AA and BA is the y value, and for I is equal to 0, and we will take z also. And how much will get? AA and B power 0, A power 0, 0 and AB. And we will take I is equal to, which is not belongs to this language, and we will also take one more length x power y power I z. So here AA and so BA of 1 AB. So we will get AA, BA, AB. So it is a combination of this belongs to this language, and we will take one more string I is equal to 2. So x I power 2 and z. So here AA, BA power 2 and AB. So AA, what is the combination? AA and BA, BA and AB. So here there is a pattern not connected with this. So here AAB is there, and here we will get after B only one A is there. There is no two A's are there. So here which is not belongs to this language. So here how we have to prove that the given language is regular or not by using this pumping lemma. So by using this pumping lemma cases, we solve that the given language is not a regular language. And we will take one more example. So here A power I language which is belongs to A power I and B power I. And here we will take I is equal to 2. Why? Because I is greater than or equal to 0. So A is equal to, I is equal to 2. So A power B power 2. And for the same, W is equal to A, B, B. And we will take this divide into a X, Y, Z. So X, Y, Z. So what is the X part? So we will take X part is only A. So this is X and this is Y and this is Z. So let's first check for the first condition. So first condition is the mod of X, Y is greater than or equal to N. So here the length of XY AB. So here length is 4 and here 3 greater than less than or equal to 4. This is satisfied. And next second condition, the length of Y is greater than or equal to 1. So first condition is satisfied and next condition Y. So Y length is AB and greater than or equal to 1. This is 2 greater than or equal to 1. This is also satisfied. And the third condition, what we have to do, we have to give some pumping length to that one. So here we already taken I value. Let's write it as a P. So and we have to prove that we will have to pump this length to the Y value and here we will take P is equal to 0, P is equal to 1 we will take and we will write, so X is equal to A and Y is equal to AB and we will give pump 1, P is equal to 1 pumping length and B we will write it belongs to regular language. Why? Because B pattern is there. And next we will take P is equal to 2. And we will write, so P is equal to X power P, that is 2 and Y. And so here the P is equal to 2 and we have to prove that AB power 2B. And here A, and we have to write 2 times AB, AB and B. So there is a pattern of AAB and ABB is there. So what is the our pattern is 2 A's followed by 2 B's. And here what we have taken, what we get, AA, 2 A's followed by 1 B and here A followed by 2 B's. So this is not a same as this one. So it is not a regular language. So here this, by using this pumping lemma, we prove that given language is nothing but here A power I and B power I. So I greater than or equal to 0, which is not a regular language. So these are all about the pumping lemma concepts and we prove that a given language is regular or not by using this pumping lemma concept. And these are the references where we have taken from the these examples, and thank you.
Like, share and subscribe. Hit the bell icon for more updates.